Hello friends, welcome to Chance Code. In this video, we are going to see how switch statements in Java works under the hood. Before we dive deep into this topic, I would like to say that if you are new to this channel, please do subscribe it. Now let's get started without waiting further. Any switch statement you are using in Java are nothing but the switch statements with integer. And by saying that, what I mean is, if you are using switch statements with no matter what data type, it is at the end going to be converted into switch statements with integers. Let's say you are using the switch statements with byte. In that case, the bytes will be typecasted into integers. Same thing happens with respect to sorts. And if we are using characters with respect to switch statements, then they are going to convert it into integers with respect to their ASCII codes. So far we have discussed that the switch statements with byte, sort and character are being converted into switch statements with integer. Now what about the other data types? For example, if you are using switch statements with strings, then they are going to convert into switch statements with integer by using their corresponding hash code values. I have made a separate video explaining switch statements with string and how hash code is being used to convert that into switch statements with integer. You can click on the info card shown above to watch this video. Now moving ahead, the enums with respect to switch statements are being converted into switch statements with integer by using their ordinal values. A separate video is available on this topic as well. Please click on the info card above to see that. Now we have seen that no matter what data type you are using with switch statements, at the end Java compiler is going to convert this into switch statements with integer. But the question is, why Java compiler is doing that? And to answer that, let's move on to the next slide. Actually, when the switch statements are being compiled by Java compiler, they are getting converted into either table switch or lookup switch. And these are the two commands which is understood by JVM and can only work with integers. And that is the reason why our Java compiler converts each and every switch statements, no matter what data type they are associated with, into switch statements with integer. Now the question is, when a switch statement is being converted into table switch and when it is being converted into lookup switch. And to know that, please watch this video till the end without skipping anything. Let's move ahead. I have taken this small switch statement as an example to explain you in detail about both the commands table switch and lookup switch. And if you observe closely, I have taken the switch statement with integer data types. And the reason is, whatever data type you are using with switch statement, at the end they are going to be converted into integers. Now let's move ahead. So for the JVM, the switch statement in the left side is nothing but the table switch command in the right side. Now let's understand the table switch command in detail. The first argument to this command, which is 10 in this example, is called as low. And the second argument to this command, which is 12 in this example, is called as high. And correspondingly, we have all the cases ranging from low to high along with the default case. Now let's see what are these L1, L2, L3 and L4. These are nothing but the labels with the code of their corresponding cases. For example, L1 is the label having the code for case 10, L2 is the label having the code for case 11 and so on. Notice that L4 label has written command instead of any code. But ideally it can have the code which is defined in the default case of your switch statement. Now as we know, JVM executes the bytecode sequentially. The break statement is being compiled into some additional labels. Notice that L5 and L6 are the labels having the command to jump into label 4, which is the final label. So this is the final bytecode representation of our switch code. Now let's understand it in detail by taking an example. Let's say the value of the input is 14. Now the JVM executes the table switch by checking whether the input value is in the range of 10 to 12 or not. Since it is not, it goes to the default offset and from there it executes the command which is written in L4 label. Now let's take another example, and in this example the input value is 11 instead of 14, and JVM checks whether the input value which is 11 in this example is in the range or not. And since it is in the range, now JVM has to find out which index it has to pick from the table, and the index is being decided something like this, and based upon the value of input and low, it decides the index. Note that items in the table switch command are in 0 based index. Now JVM will execute L2 label and then L6 label and then jump into L4 label. Now let's look into the same example without break. In this case, after finding the index, JVM jumps into that label, executes it, then the label below it, then the final label. Moving on next example, we have a bigger switch statement now. Moreover, this is slightly changed and we don't have a case 12. So the low and high argument of table switch command are changed accordingly. Now let's say the value of the input is 12, and when JVM checks whether 12 is in range or not, it finds it is in range, but the index of the item cannot be picked in this case. So to avoid this situation, what Java compiler does is it creates a fake label of 12. And if you notice clearly, the label associated with it, which is L4 in this case, is the same label associated with the default case. Now if the input value is anything between 10, 11 and 13, it goes to corresponding labels like L1, L2 and L3. Whereas if the input value is 12 or anything else, that goes to L4 label. Hope you so far understood how table switch works with respect to the switch statement with sequential cases and switch statement with some skipped cases. Now let's move ahead and take a more complex switch statement as an example. As you can see, this switch statement is neither having sequential cases nor having some skipped cases. Instead, it is having some random cases. Based on our learning so far, we can assume that the low and high value of table switch can be converted into 10 and 30. And accordingly, there can be lot of fake entries. But this is very inefficient because in the source code, we have only 3 cases and a default case, whereas the bytecode has all these 4 cases including default, and in addition to that we have 18 fake entries. Moreover, if the cases are too random, for example one case is like case 10 and another case is like case 1 lakh, in that case we might end up with lakhs of fake entries, which is completely inefficient. And to solve this kind of problems, the Java compiler converts this switch statement into lookup switch instead of table switch. As you can see, lookup switch don't need any fake entries. Now let's move ahead and understand a bit more about lookup switch. And the first thing to notice here is the argument to it, which is the label count, and it represents the number of cases in the source code excluding the default case, which is 3 in this example. Now let's see how JVM executes this with an example. Let's say our input value is 20. Instead of calculating the index of the item, JVM tries to compare the input value with each entry. For example, first it compares the input value with the first entry, which is 10 in this case. It doesn't find the match, so it goes to the next entry. It finds the match and the corresponding level is L2, so it jumps to the L2 and executes the code. And once it finds the proper entry, the rest of the execution is as same as the table switch. Hope you now understood what is the difference between table switch and lookup switch and when they are both used. Now let's summarize both of these. Our switch statements are being converted into table switch if the case values are consecutive or can be optimized to consecutive. Whereas if the case values are completely non-consecutive or random, in that case the switch statements will be converted into lookup switch. Table switch takes more memory because there can be some fake entries, whereas lookup switch takes less memory as compared to table switch. Table switch is more efficient because in this case JVM directly calculates the entry and jumps into the label to execute it, whereas lookup switch is less efficient as compared to the table switch because in this case JVM has to compare the input value with respect to each and every entry of the lookup switch. And last but not the least, both of these commands have table entries which are completely sorted. I hope you understood how switch statements work internally in Java and how Java compiler chooses between the table switch and lookup switch command and what is the difference between them. Hope you learned something new out of this video. If you liked this video, please do like, share and subscribe to our channel. Thank you. Thanks for watching.